What's going on, guys? Welcome back to the channel. Today we're going to be going through the full guide of algebra, okay, for the A-level mathematics CIE course 9709. Okay, now most platforms are going to charge you for this. This is a full guide of algebra. You know, all the key things: factor theorem, remainder theorem, modulus functions. Basically a full crash course. So you've got everything you need here, and minus, of course, the extensive questions, but we can go over that another time. But yeah, without further ado, enjoy the video, guys. Starting off here, we're going to look at the modulus function. Okay, so what is the modulus function? Very simple. It's basically just the absolute value of x. Okay, that's what these bars mean here. And so if x is greater than or equal to 0, it makes sense that the absolute value of 4, okay, is going to equal 4, because 4 is bigger than 0, right? And at the same time, okay, if we have minus 4, right, then the absolute value of that is going to equal 4 as well, okay? And this is basically what this here is demonstrating, okay? So that's just a brief overlook of what the modulus function is, how it works, right? And without further ado, let's get into some graphs. So the modulus function is best illustrated when looking at a graph. So as you can see here, with y equals x minus 1, here we've got a constant gradient, okay? It's a constant positive gradient. And over here, okay, we've got an absolute function of x minus 1. And so our gradient changes depending on the x value, meaning actually that it changes here at x equals 1. Now, why is that? Well, remember that here we're looking at the absolute value of x minus 1. So we're never going to have a negative value for y, okay? And so what we actually get is the function y equals x minus 1, okay, for x greater than or equal to 1, okay? And then we also get y is equal to minus x minus 1 for being smaller than 1, okay? And that's what we've got here, and then obviously follows this kind of logic as well. So that's the key difference here, okay? It just the absolute value bars here, they just change the way the graph looks because everything is going to be positive. Alright, now what happens if we get an equation? We get an equation like this, and it wants us to solve it. It wants us to solve the modulus of x minus 1 is equal to the modulus of 2x. What do we do? The method here is to basically, one way to go about it is to draw the graphs. Okay, and that's what we've done here. So as you can see, we've got the modulus of x minus 1 here. Okay, and we've got the modulus of 2x over here. And so we've also got two intersection points over here and over here. So let me just get my pen and let's label that. Okay, let's put that there and that there. Okay, we've got two intersection points here. Now, as you'll notice, one of the intersection points is on this side of the graph, i.e. when x is bigger than 0. And one of the intersection points is on this side of the graph, i.e. where x is smaller than 0. And the way to solve this now is to basically evaluate the intersection points at the different points that these graphs meet. So if we start from right to left, over here, the absolute value of 2x is positive. So we're going to have 2x here, and that's meeting the absolute value of x minus 1 when it's on its negative gradient. So it's going to be equal minus x minus 1. And so if we solve that, we get 2x is equal to minus x plus 1. Then we get 3x is equal to 1. X equals a third. Okay? And we can plug that now into any of the any of our functions here. The easiest one would just be to plug it into absolute value of 2x. So therefore, we say the y value is going to equal 2 over 3. So we got a third, 2/3 as our first point there. That's this done. Now, what about this bit over here? Well, as you can see for this bit on the left, it meets, the 2 points meet on the absolute value of 2x's negative gradient, so minus 2x, okay, and it also meets on the absolute value of x minus 1's negative gradient. So it's minus 2x is equal to minus x minus 1. So then we get minus 2x is equal to minus x plus 1. So we get 3x, sorry, not 3x. We're going to get minus x is equal to 1, x equals minus 1. Okay. And with that, we just plug it in. And we can just plug it into our absolute value function here. And that's going to give us a y value of 2. So therefore, our second point is minus 1, 2. Okay. And that, guys, is going to be the answer to this equation. Okay, as you can see, we basically just drew the two graphs, 2x for a positive gradient, 2x for a negative gradient, therefore altogether creating this absolute value. And then we drew x minus 1 for a positive gradient and also negative gradient, and we evaluated at these different points. And that's how we got a third 2 over 3, a negative 1 and 2. Alright guys, now as for the second method, we've got squaring both sides. Now this is often a much quicker and more efficient way to actually go through this, because most of the time in the exam, you're not going to have time to draw the different graphs. You're not going to have time for that. And most often, it's just easier to square both sides in order to get the answer you want. So, we've got x minus 1 is equal to 2x, right? We got that. So, let's square both sides. We get x minus 1 squared is equal to 2x squared. So, we get x squared minus 2x plus 1 is equal to 4x squared. Okay, let's get minus 2x plus 1 is going to equal 3x squared. And from here we can say 3x squared plus 2x minus 1 is equal to 0. Now, I'm pretty lazy, so all I'm going to do now is I'm going to plug this into our quadratic formula. So I've got x is going to equal minus 2 plus minus 2 squared minus 4 negative 3 now minus 1 over 2 times 3, which then gives me, we can simplify this down, and x is equal to minus 2 plus minus root 16 over 6. Okay, and here we've got a few values we can get from it. So we obviously get x equals a third, or x equals minus 1. And of course, we know from before, if you plug this in, therefore y is going to equal 2/3, okay, or y is going to equal 2. Okay, so same answer, but obviously different way of doing it and a lot quicker. Alright guys, so here we've got the value of absolute value of 2x plus 3 being greater than 5x minus 1. Okay, so how do you go about doing this? As you can see here, we've drawn the graph, okay, where we've got the absolute value of 2x plus 3 here and the absolute value of 5x minus 1 here. Now, obviously in the exam, you're not going to have that capability to, access graphing software to quickly do this. But I think for this purpose, it's nice for a demonstration. And so, starting off, as you can see, we've got 2 intersection points. Okay, we've got 2 intersection points here. And we're going to say 2x plus 3. Okay, because we're getting it on the come up. And we're going to set that equal to 5x minus 1. It's positive gradient as well. And so that gives us 3 is equal to 3x minus 1, which equals 4 is equal to 3x. X is equal to 4 over 3. Brilliant. So we've got x equals 4 over 3. If we plug that into 2x plus 3 now, the positive variance, 2 4 over 3 plus 3 is equal to a over 3 plus 3, okay, which is going to give us 17 over 3, which is the same thing as 5.667. Okay, so that's our first kind of point here. We got 4 over 3, 17 over 3. Fantastic. Brilliant. Now, we've also got our second points here. So how do we get to this? Well, it's going to be 2x plus 3 of the positive variance equaling to minus 5x minus 1, okay? Because now we're going on the negative variance of the modulus function here. So minus 5x minus 1. That's going to give us 7x plus 3 is equal to 1. And that's going to give us x is equal to 7x minus 2. Okay, x is equal to minus 2 over 7. Right, if I just quickly check that, that's correct, yes. And so if we plug in x equals to minus 2 over 7, we plug that into the positive variance, 2x plus 3, we should get the answer for y here. So do 2 minus 2 over 7 minus 4 over 7 plus 3. Okay, that's going to give us 2.42 857. Okay, that's the same thing as saying 17 over 7. Okay, so we've got this, and we also got this as your final answers. Okay, same process, nothing special, just a little bit more of tricky numbers involved, but nothing else. Alright guys, now chances are in an exam it's going to be very cumbersome to draw those graphs and do it that way. So it might not be, but sometimes it is. So one way to kind of come around this is obviously to use a squares method. So here we'll just say we're going to let 2x plus 3 squared equal 5x minus 1 squared, okay, which gives us 4x squared plus 12x plus 9, okay, is equal to 25x squared minus 10x plus 1. Alright, and so what do we get here? We get 12x plus 9 is going to equal 21x squared minus 10x plus 1. Okay, and we get 9 12 22x plus 1 right, it's a bit of an ugly equation here. Okay, we set that equal to 0. And, you know, in the case like this, you have to be cute about it. You can just plug into quadratic formula. So we've got 21. Okay, we've got minus 22. Got minus 8. Alright, and if we go here, so we got x is going to equal 22 plus minus minus 22 squared minus 4 21 times 8, that should be minus 8, sorry. Okay, over 2 21, which gives us 22 plus minus the roots 1156 over 42. Okay, which is going to give us 34 over 42. Okay, and that's going to simplify down. So x therefore is going to equal same as before, 4 over 3 or negative 2 over 7. Okay, from here, and plugging in, we know that we're therefore going to get 17 over 3 or 17 over 7. Okay, so that's going to be the final answer using the squares method. A little bit different. By all means, use whatever method you want, but this can often be quicker if you're stuck on time. Alright guys, so here we've got a example of a graph of the form y is equal to ax, okay, plus c. Now, what has gone on here? Okay, what has gone on here with 6 modulus x minus 8? The way you kind of draw a graph of this form, okay, is to start off here. Okay. Over here we've got modulus x. In fact, let me draw that. Let me put that in red. Okay. We've got modulus x here. Okay. Our initial graph. What we've done here, okay, is we have basically stretched it by a factor of 6. Okay. And it's stretched in. Okay. So here we've got 6 modulus x. And lastly down here, we've reduced it down by 8. We've shifted it down in the direction of minus 8. Okay, so we've shifted down, so which is why we get 6x minus 8. So that's just a quick little summary on how you go about drawing a graph like this. Okay, again, you start off with modulus of x, you then scale it by a, okay, and lastly, so you stretch it by a, and then lastly translate, okay, by c, and c here is minus 8. If it was plus 4, it'd be different, we'd be up here. Okay, but we've shifted this graph down. Alright, and I mean, it's no need to really go on much more there. I mean, that's pretty simple. That's basically it. Hey guys, so now we've got a very important part of the algebra section, and that is dividing polynomials. So this applies for all algebra in general here in this course, but especially dividing polynomials, you're never going to get a question really that says divide this by this. It's usually linked to something else, which is why it's important nonetheless to be prepared and have your skills honed up in these types of areas. So the way we go about doing this is we're going to say x plus 1 here. I'm going to say 5x squared plus 3x minus 2 over here. Okay. Like that. And what we're going to do now is we're going to firstly, okay, it's that long division. I'm going to get the x, I'm going to go in here. And how many times does x go into 5x squared? Well, it goes in 5x. And then what we do is we then multiply 5x back in. Okay. So I usually put a minus there and brackets to remind us of what we need to do next. So 5x times x, 5x squared, 5x times 1 is just 5x. We're still at the minus 2 there. Okay. If we do that, what we're going to get? We're going to get 3 minus 5. So 5 minus 5, 0. 3 minus 5 minus 2x. Minus 2 minus minus 2. Well, that's... sorry, no, minus 2. It's just going to be... yeah. Let me see. Yeah, no, we're just going to bring that down, sorry. So we've got to get a minus 2 here. Okay, perfect. Now it's, how many times does x go into minus 2x? What goes in minus 2 times? Okay, brilliant. And we're going to minus something here. That something is going to be minus 2 minus 2x. How many times does that go in? Well, we've got minus 2x here. Okay. Then we've got minus 2 here as well. Alright. And this is going to give us 0. Alright, so very simple example here. Very simple example. And as you can see, what does this show us? The remainder is 0. The remainder is 0. But what we know now is that 5x squared plus 3x minus 2 is equal to x plus 1 times 5x minus 2. Okay, and that's what we've set out to achieve here. So very simply, it's like long division. Okay, pretty much exactly the same. Okay, times in, sorry, you find out how many times that's to go in, and then you times on the outside, and you just repeat. Alright, so a bit more of a complicated kind of question here. Another polynomial division. Okay, we've got this polynomial divided by 3x minus 2. So we're going to set it up as we always set it up. We're going to say 3x minus 2. Okay, and that's going to go into 6x cubed plus 11x squared minus 31x plus 15. Okay. Right. So, how many times is 3x going to 6x cubed? Well, that goes in 2x squared times. Okay. And then we do 2x squared times 3x. That's 6x cubed. Okay. Minus 4x squared. Brilliant. Nice. We get that. Then we're going to minus. So 6x cubed minus 6x cubed, that's 0. Okay, now 11 minus 4x squared. So 11x squared minus 4x squared, that's 15x squared. So you got 15x squared here minus 31x. Okay. And I'm going to ignore the 15 for now because we can just bring that down at the end. Okay, so we got this. Now we're going to say, well, what's 3x? How many times does 3x go into 15x squared? Well, that goes in 5x times. Okay? 5x times. Alright? So now we do it. Now we repeat. 5x times 3x is 15x. Okay, minus 10x. Brilliant. Okay, and we do 15 minus 15x, 15x squared minus 15x squared, 0. Negative 31 plus 10x, that's negative 21. Negative 21x. Okay, remember the 15 was still technically bringing it down, but there's no point writing it down just for simplicity's sake. Let me move this up a little bit. Now 3x going into negative 21 is, that's just my negative 21x. Sorry, see, it's a lot of syllables here. That goes in minus 7 times. Okay, brilliant. And again, we've got our brackets. Okay, negative 7 times 3 is negative 21x. Negative 7 times negative 2 is plus 14. And this is where the 15 comes in useful. Because now we've got negative 21x plus 21x is 0. But we've also got 15 here. Okay. And that plus 15 is going to be minusing 14. So therefore, we're going to get plus 1 as our remainder. Now, what does that look like? What does that look like? Well, if we've got a remainder of 1, what we're going to say is we're going to have this. So 6x cubed plus 11x squared minus 31x plus 15. If we divide that by 3x minus 2, what we get is 2x squared plus 5x minus 7, okay, plus 1 over 3x minus 2. Okay, so our remainder here. Okay, so that's what we've solved. Just as a recap here. Again, we go in 3x into 6x cubed, 2x squared times, and then we multiply the 2x squared back into 3x minus 2. And we repeat and we repeat. Okay, and eventually we get a remainder of plus 1. Okay. And that's basically it for division of polynomials, guys. Nothing too hectic or strange. It's just a case of practicing when you can. It's not too important, but you want to be on top of it for sure, because if it comes up and you can't do it, then that's going to be a problem. Alright guys, now in this example, we've actually got an example from the textbook, right? The Oxford version. And basically what it's saying is, when this polynomial is divided by 2x minus 1, the remainder is 3, and it wants us to find the value of a. So this is a classic type of remainder theorem question that's a bit more practical, and it wants you to be a bit more, it's using the remainder theorem to solve a problem. In this case, find a. Okay, so you get these a lot. Also quite simple though, because simply we know that f of x here is equal to 16x to the power 4 minus ax3 plus 8x squared minus 4x minus 1. Okay, and it's divided by 2x minus 1. Okay, it's divided by 2x minus 1, which means that the remainder must be the value. Okay, if this is 2x minus 1, okay, so here, right, we've got x minus k, then the remainder is the value f of k. Therefore, if we've got 2x minus k, or ax minus k, therefore the value of the remainder must be k over a, right? Because remember, it's just like saying it equal to 0. If we've got ax minus k equals 0, therefore ax equals k, x equals k over a. Okay? So taking that, we can say that, okay, f of a half, that must be the value here. Okay, that must be the remainder. right? So what I can say is f of a half equals 3. Main theorem. Okay. Therefore, I can say 16 half to the 4 minus a half to the 3 equals 3. Okay. And if we combine this all together, what we get is minus an eighth a equals 3. Therefore, a is going to equal negative 24. Okay. So just as a reminder there, 2x minus 1 is being divided by. Therefore, we know that f of a half is going to equal 3. Okay. According to this theorem, okay, f of a half is equal to 3. Therefore, all we have to do is plug in a half over here and set it equal to 3 here, and therefore we can find a. Alright guys, now a very important part of the algebra section is the factor theorem. Okay? Very important. So similar to remainder theorem, basically what we're saying here is it says according to the factor theorem, k is a 0 of f of x if and only if x minus k is a factor of f of x. And as usual, I want to do an example to demonstrate this. So if we look here, okay, if we try factorize this, we can. What we get is 4x, x plus 2. Over here, we can factorize this to get x plus 2 squared. And over here, we can get x squared minus 6x minus 1 plus 30 over x. Now, as you can see, this is a bit of a troublemaker. Okay, we haven't actually factorized it as much as we like. So what do we do here? And that brings us onto the next phase of how the factor theorem works. So I'll demonstrate that now with an example. So this is a classic example of the types of questions you'll be asked, right? Here it says factorize x cubed minus 6x squared minus x plus 30. Given x plus 2 is a factor. This is what they often say. And we've been doing this already, right? We just haven't put the factor theorem label on it. Because to do this, all we have to do is say, well, listen, x plus 2 is a factor. So we can just use long division to find the answer here. So if we go here, we've got x cubed minus 6x squared minus x plus 30, right? What we can do is we're going to say, okay, x goes into x cubed, how many times? Well, that's x squared. Okay. Minus x cubed, okay, plus 2x squared. Perfect. Brilliant. And that's going to give us what? Well, minus 6, minus 2x squared. Okay, that's minus 8x squared. Okay, and we have minus x plus 30. Then we've got, well, how many times is x going to minus 8x squared? What's minus 8x? Okay, and we, again, minus, and then we get minus 8x squared minus 16x. Okay, I'm just going to drag the 30 here. And over here, we're going to get, well, 15x, right? And it's going to be 15x plus 30, right? Because again, minus 8 plus 8 is 0. And from here, x goes into 15, well, 15x, well, plus 15. Okay. And multiply that out again. 15x plus 30. And we're left with 0. Okay, so obviously here, we've demonstrated that if we get 0, okay, according to here, right, we've factorized this. So therefore, okay, we can say that x cubed minus 6x squared minus x plus 30 is going to equal x plus 2 x squared minus 8x plus 15. Okay, and that's going to be the answer here. Okay, very simple. Again, k is a 0 of f of x if and only if x minus k is a factor of f of x. So we've shown here that we've got the remainder 0. Okay, and we're given that x plus 2 is a factor, so all we've had to do is show that it's 0, and therefore we've factorized it as required. Alright, now we've got another question that says factorize x cubed minus 5x squared plus 2x plus 8 given x plus 2 is a factor. Right, now in a situation like this, one thing I didn't mention before is that oftentimes we can have a little shortcut here. Okay, so usually we can think about this. Okay, so how to proceed. Okay, we can do long division. Okay, or we can try a value for x. And often in an exam environment, this is the quicker option because a lot of the time, you know, you're stuck for time and you want to do things quickly. And this is a way to quickly get something done and avoids the possibility of making a mistake to a much larger extent. That being said, long division is a concrete way, but if you want a quick shortcut, this is one way to do it. So how do we go about doing that? Well, we can say that, okay, what's f of x? Okay, so f of x is equal to x to the power 3 minus 5x squared plus 8. Okay, now plugging in different values for x. F of 1, what does it give me? 1 minus 5 plus 2 plus 8. Okay, that, okay, is not going to give me 0. What about f of minus 1? We use minus 1, we get minus 1 minus 5 minus 2 plus 8, and what do you know? This equals 0. So when we plug in minus 1, we get 0. Okay, and what does that mean? Well, if f of minus 1 equals 0, therefore it implies that x plus 1 is a factor. Okay, right? X plus 1 must be a factor according to this. Remember, yeah, x plus 1, which is like x minus plus 1, right? And that kind of equates here as well with f of x. So x plus 1 must be a factor here, right? Now, what else can we say? F of 3 equals, so we do 3 cubes plus 5 times 9 plus 6 plus 8. Okay, that's going to equal minus 4, which doesn't equal 0. Not a factor. Okay. And what if we do f of 4? Well, if we do f of 4 here, right, if we do f of 4, this will be 4 cubed minus 5 times 16 plus 8 plus 8. Okay, so 4 cubed minus 5. Well, that's going to equal 0, right? F of 4 equals 0. And therefore, if f of 4 equals 0, therefore, what that means that x minus 4 is a factor. Okay? That's important. So now we've got two factors here. We've got x minus 4 and we've got x plus 1 as factors. Right? And so we can break this up now. We can say that x cubed, right? We can say that x cubed minus 5x squared plus 2x plus 8, that's going to give us x plus 2, x minus 4, okay, and x minus 4 and x plus 1, okay. And as you can see, we have fully factorized it. So as a recap, we've quickly done this by plugging in different values for x. Now this is often intuitive based, right? So you kind of need to have the intuition to see what types of values could work here. But if you get it right, and if it seems pretty simple enough, then it can save a lot of time. But alternatively, long division is a good way to go as well. Alright guys, now lastly we've got a quick exam style question here as well on the factor theorem. And it says the polynomial x to the power 4 plus 3x cubed plus x plus b is denoted by p of x. Okay, and it says when p of x is divided by x squared plus x minus 1, the remainder is 2x plus 3. And it wants us to find the values of a and b. So how do we go about doing this? Well, the first thing I'm going to do is I'm going to use long division. So x squared plus x minus 1. Okay, and we're going into x4 plus 3x cubed plus ax plus b. Right? If we use long division here, we get x squared here, and we multiply that back in. We get x4, okay, minus x squared. Alright, and that's going to give us, we get 2x3, okay, plus x squared, because remember it's 0 minus x squared, so plus, okay, we get plus ax plus b, okay, and then we go x squared into 2x cubed, that's 2x, okay, we plug that back in. We get 2x cubed plus 2x squared minus 2x. Okay. And if we do that, we're going to get minus x squared plus 2x plus ax plus b. Alright. And if we go back into that, with the x squared, we get minus 1 up here. Okay, multiply back out. We're going to have minus x squared minus x. Okay, minus plus 1. Okay, which is going to give us 3x plus ax plus b minus 1. Okay, just quickly, this is quite long. All we've done here is don't be confused by the constants a and b. We've done the exact same thing as we were doing before. We've just made it a little bit more quick here to save time, but the principle's the same, and this is what we get at the bottom. Okay, now we can say now that given remainder is equal to 2x plus 3. Okay, that's what we're given here. We can therefore say that 3x plus ax plus b minus 1 is equal to 2x plus 3. Because remember, this is the remainder as well. And if this is the remainder, therefore we're going to set them equal. Right? And if we factorize this now, what we get is 3 plus ax plus b minus 1 is equal to 2x plus 3. And now it's a simple case of just comparing coefficients. So we could say, compare coefficients here. 3 plus a is equal to 2. So a is going to equal minus 1. Comparing constants, b minus 1, okay, is equal to 3, which means that b is equal to 4. So therefore, a is equal to negative 1, and b is equal to 4. Simple. Simple as that. We did the hard part up here. This is the part where they want to trick you out. And this is what we kind of conquered in the beginning. Okay? Same principle as usual with polynomial division. Don't be confused by the a's and b's. We just did it methodically, and we got to this answer. Okay? And given that the remainder is 2x plus 3, you just set them equal. Simple as that. And then just factorize this. And 3 plus a must equal 2 by extension, and b minus 1 must equal 3. Therefore, we get a equals 1, negative 1, and b equals 4.